Balloons are a really useful way of studying the atmosphere. They get to heights, they get to places which are otherwise very difficult to access. A balloon is a great vehicle for exploring the atmosphere of Venus, and we're in a hot air balloon today to demonstrate what it might be like flying around on Venus. Weather balloons measure temperature, pressure, gas composition, all as a function of height above the ground. Winds are very difficult to measure because the air is transparent, but if you send a balloon up and you track where the balloon goes, that tells you about the winds in the atmosphere. Balloons are also really useful for looking at clouds. If you've got instruments on your balloon which will measure cloud properties, measure the chemistry of the clouds, measure the droplet size, then that'll tell you a lot of information about the clouds. When the Dutch astronomer Christian Huygens started looking at Venus in the 17th century with telescopes, he saw that the outlines of Venus and the outlines of the day-night boundaries were a bit blurry, and he said, "Is it not all atmosphere that we see?" And he was right. So Venus and Earth were formed at about the same time, 4 billion years ago, and out of the same materials, so you'd expect them to be quite similar. You'll find many similar features on Venus as on Earth. You'll find volcanoes, you'll find highlands, you'll find lowlands. But the similarities really end there, because once you get up into the atmosphere of Venus, the climate is very, very inhospitable. The atmosphere is almost entirely carbon dioxide. The surface pressure is 100 times greater than that of the Earth. And of course, carbon dioxide is a greenhouse gas. So this very thick carbon dioxide atmosphere on Venus gives rise to an enormous greenhouse effect, which cooks the surface up to 450 degrees centigrade. So on Earth, the clouds are indicative of water coming up from the surface and rising and forming clouds. So the fact that there are clouds everywhere on Venus, and they're mostly made of sulfuric acid, could be indicative of large sources of sulfate gases from the surface. So what could this source be? Well, there's some evidence to suggest that the volcanoes on the surface of Venus are still active and belching out sulfate. There's a European satellite orbiting Venus as we speak. It's the first European mission to Venus, and it's called Venus Express. There are many things we're finding out from Venus Express, especially global phenomena, so global winds, global oscillations in the atmosphere, the kind of things we're getting from weather satellites on Earth. But that's not the entire picture. There are things which we can't study from satellites. Observing a planet from a satellite is a bit like trying to study a cake from afar just by looking at it. You can get a lot of information by looking at it. You can see how it's structured, you can see what color it is, you can even guess at what sort of ingredients might be in it. But if you really want to study it in detail, you have to get in there, you have to get your hands dirty, and you have to take a bite. Yum. I think that's what I'm going to do now. There are many important questions to be answered if we are to understand how Venus works and why Venus ended up so differently from the Earth. Venus is a great place to explore by balloon, because if you're floating around at the cloud tops on Venus, you'll have conditions very similar to this. You'll have temperatures of maybe 20 degrees, 10 degrees centigrade. You'll have pressures, atmospheric pressures, very much like this. But the difference between here on Venus is that here we're just 500 meters or so off the ground. But on Venus, if you looked over the edge of this basket, you'd be 60 kilometers up. You'd be way, way above the ground. And another advantage at this altitude is that we have very, very strong winds. Since these winds are so fast, they'll take you around the planet in your balloon in about a week. We're proposing a mission called the European Venus Explorer to go back to Venus. So this would be a very large mission. We'd have a rocket which would launch in Russia, and then that spacecraft would travel through space until it gets to Venus, and this would take only about 5 months. Venus is the closest planet to Earth in terms of spacecraft travel. Once it gets to Venus, then the spacecraft will go into orbit around Venus, but not before releasing 2 vehicles into the atmosphere of Venus. One will be a balloon, so it'll come in through the atmosphere behind a heat shield, It'll be coming in at very, very high velocities. You'll have burning gases going past the spacecraft, and then ultimately it'll slow down under a parachute, and then it'll have to deploy a balloon from behind a parachute, which isn't particularly easy, but it's been done before, and we're fairly confident we can do it. So this balloon will then drift around Venus for hopefully about 2 weeks or so. And then the other vehicle is a descent probe, which will come down all the way through the atmosphere and reach the surface. And of course the conditions at the surface are so inhospitable that the descent probe will only last for about an hour or so at the surface. There are many partners involved in this mission, in addition to many European nations and Russia as well. There are partners from the US, there are partners from Japan. The European Venus Explorer mission would be an obvious next step after Venus Express to keep Europe in the forefront of Venus exploration.
O objetivo é estudarmos a atmosfera.
Os balões vão para o céu e depois rebentam e os postais caem.
Like being a kid.